Today we'll be modeling a circuit to be used in a practical application. Our design today includes a capacitor storing a voltage potential to then be released when a switch is flipped. When the switch is flipped, the capacitor will power the LED without the use of any other voltage source. This is a great model for emergency power sources that do not need to rely on batteries or a supply voltage source. Our circuit analysis will be based on the conservation of electrical energy. When the switch is flipped to the voltage source, we can construct a KVL loop as shown below. The KVL loop will consist of the voltage across the capacitor, the voltage across the resistor, and the voltage source. When putting the voltage stored in the capacitor in terms of the voltage source, we can see that the voltage across the resistor is directly proportional to the voltage stored in the capacitor. When the switch is flipped to the LED side, we see that the 47 ohm resistor that we are using, as well as a potentiometer, are in series. So, putting them together, we can see that the voltage of the capacitor in terms of the voltage source is equal to the voltage across the potentiometer. Applying Ohm's law with the potentiometer and resistor now in series, we can then solve for the current flowing into the LED to check to see if it's safe. Here's the demonstration of the circuit below. As you can see, I have charged the capacitor for 20 seconds and am testing to see the voltage potential it has. With a voltage source of 2.89 volts, our capacitor now has a charge of 2.85 volts, which is shown on the voltmeter. I also tested the resistor to see the voltage potential, and as we should notice, it is 4 milliamps shown on the voltmeter. This proves the voltage potential across the resistor decreases as the charge on the capacitor increases. We now will flip the switch, and it will be shown the light being able to be controlled by the potentiometer, as you can see it getting dimmer and brighter. The switch is now flipped. The battery source is now unplugged. As you can see, it begins dim with a resistance of 10 kilo ohms on the potentiometer. And now when the potentiometer is turned, you can see the light getting brighter. We can now back up this demonstration using our Excel spreadsheet. When our source voltage is 2.89 volts, our capacitance, our resistance, and our potentiometer resistance when at its lowest point is inputted, as well as our time. We could see the capacitor voltage is 2.849 volts, which backs up our demonstration of 2.85 volts. We can also see the voltage of A before when it is charging to be 4 millivolts, which also is backed up by our claims, as well as the voltage across the potentiometer shown to be exactly the same as the voltage across the capacitor when the switch is flipped to the LED side. For a fun fact, we could see that the current going into the LED is 58 milliamps, which is between the peak forward current and the forward current for the LED, which shows that this is safe and will not short the LED out.